It's time to move on to our final session of the day. I'd like to invite on stage, any ideas? Mr. Rajiv Sanghvi, please, let's see you on stage. International Councillor, SPE India. I would also like to invite on stage Mr. Girish Samudra, Mr. Prashant Nikare, Mr. Chanchal Das Gupta, and Mr. Haresh Pillai. Please put your hands to give them what? Please put your hands together and give them a loud round of applause. Haresh, stop distracting me. Okay, you want to come later? All right. I will now hand over the mic to Rajiv Sanghvi to moderate the session.
Good evening. We are at the grand finale, and we hope we can have your attention for the last few minutes. I just want to make 2-3 clarifications because a lot of people, a lot of delegates are asking. The presentations will be available to everyone in PDF format. It will be in a download link. Yeah. I'll repeat that. There will be a link available to you wherein you'll have to give your feedback on the conference. And once you fill in the feedback, you will get a link to download the presentations. So this will come to your email probably in another 10-15 days. The second announcement was that, already Ramesh had made an announcement that the first year of SPE membership is free for the delegates. So you still, if you have not enrolled yourself, you can do it after this session. Actually, the annual membership fee is 1250 plus GST, but and the admission fee is 1000. But for the first year, you don't pay the admission or the annual membership. Thereafter, you only pay the membership fees every year. That's 1250 plus GST. Okay, getting back to our sessions. Our first speaker is Mr. Girish Samudra. He has been a very ardent supporter of plastic pipes. He's been giving his speeches earlier as well. I would like to introduce him. He's going to speak on challenges and case stories of HDPE pipes in submarine applications. Mr. Girish Samudra, Managing Director, is a graduate mechanical engineer and has been in the field of HDPE piping systems, design and implementation since last 30 years, out of which he has spent 10 years in the projects and development of Polyolefin Industries Limited, a leading manufacturer of Hasti brand HDPE pipes. Subsequently, Mr. Samudra opened up a business line in the name of Flow Lines, providing erection service for HDPE pipes. And over this period of 16 years, the Flow Line team, under his strong leadership, has devoted itself exclusively to laying of HDPE underwater, overground pipelines of all sizes, starting from 250 mm OD to 1600 mm OD for multiple applications. Mr. Girish Samudra, please.
Namaskar and a very good evening to all of you. And thank you SP for giving me a talk before a very high profile audience. As my subject is challenges and case stories of HDPE pipes in submarine applications. When you hear the word submarine application or offshore application, you know that there are challenges. There are definitely challenges. I have been in this field for last more than 30 years. And still, I can't say that I have understood the challenges completely. Every new project we do offshore, the sea teaches us something new. And this has been happening until our recent projects done. So I will not say that I really know all the challenges which are faced in laying of submarine pipelines. So let me begin the presentation. Before we go to the challenges, let us just quickly see the applications for which HDP pipes are very popularly being used. The most popular applications for which HDP pipes in India are used is, one is water intake pipelines. What for this water is drawn is basically the desalination projects. One has to take these raw sea water from the deep sea through a pipe. Second application is reject water and treated effluent pipelines. Reject water is what which is generated out of desalination process, in which about 40% water is converted to potable water and the rest 60% becomes highly saline water which needs to be disposed of like a treated effluent. Of course, treated effluents from industries or industrial parks or industrial estates, outfall pipelines have been more or less made compulsory for all these sectors. So HDP pipe is very popular in going into such applications. I remember in 1985 to 87, when I was working for Polyolefins, we did some demonstrations and I held some workshops for crossing of the rivers and creeks in Kerala region. As everybody knows that Kerala is infested with backwaters. So any water supply pipeline which is traveling, a trunk main has to cross 2 or 3 water bodies. So we had advocated use of HDP pipes over there for creek crossing and backwater crossing. I'm happy to say that now they have almost 25 such installations where they have avoided construction of a pipeline bridge and they have gone below the creek bed using HDP pipe. A very unique application is dredge slurry disposal pipeline. We all know that when a port is developed or when a port is in operation, it requires maintenance dredging, where the soil from the port area is to be removed and disposed of in the deep sea. HDPE pipes being very flexible and elastic in nature and very light, they serve a very good purpose in the dredging operations. They put about a kilometer or 2 kilometers of HDPE floating pipe and dispose the sand or silt from the port area to a deep sea. Now, before we come to the challenges, let us see overall what are the key requirements of a typical submarine application project. Firstly, we have to see the overall feasibility and we have to go for selection of material. Although in 90% of the submarine installations, HDP pipes are used, but still some of the applications may not recommend use of HDP pipe. There can be such applications. The most important thing is reconciliation, survey and assessment of marine conditions and the site conditions. This is the very essential requirement of a submarine project. Third and very important is addressing the local habitat issues. Almost 70% of the pipelines I have done, they had objection from the local habitats, which are mostly fishermen. They have a very common grudge against any pipeline going into the sea that it will kill the fish and we will lose our livelihood. I have gone through projects which were stalled for more than 2 years, 3 years because of the fishermen not permitting the installation. So it is a very important thing. Before you start the project, you have to initiate the client to settle with the local habitat so that there are no problems created during the installation process. Pipeline stability arrangement, of course, that I will come to that later in the technical. Near shore leveling of intake pipe, this is also covered later on, and dredging for the pipe trench. This is also covered later on. Installation and assembly of the pipeline. This is site specific. Not everywhere we do the pre-assembly of the pipelines. but it is site specific. For a float and sink method, towing, positioning and sinking of the pipeline is one very important avenue of the whole process. When we go for seawater intake systems, we have to install a seawater intake head at the end of the pipeline so that sediment PA water can travel into the pipeline. And for a reject water or effluent disposal pipeline, there is a diffuser which diffuses the fluid into multiple streams to get the proper dilution and dispersion. Now, we are all here to discuss polyethylene, and I am proud to say more than 90% of submarine installations, HDP is part of it. Why? Because of its specific properties. One is excellent flow characteristics, and added to it, there is a high resistance to formation of scaling for HDP pipes. So for submarine applications where the chances of scaling are very high, HDP pipes are more suitable. Resistant to seabed changes. You know, the seabed keeps on changing every season. Sometimes it gets filled with sand, sometimes the sand gets eroded. HDP pipe can easily adapt to such changes. There is no free spanning of HDP pipe. Its elasticity permits it to, change the seabed very quickly. Long life expectancy, because basically PE is immune to seawater corrosion, so it lives its complete life without any hassles. Quick and eco-friendly installations. We know that it doesn't require too many barges and too many cranes and this like that for installation. Corrosion, abrasion and chemical resistance I already mentioned. Life cycle expectancy, as I said, it lives normally for its designed life, which is 50 years, because it has no effect of seawater on its material. It gives you lowest unit delivered cost of water because of high flow characteristics. We have heard the problems of metallic pipes. Mr. Salvi has very elaborately given, like he said, 1,000 words for a photograph, and we have seen the photographs, what condition the pipes were. This doesn't happen with HDP pipe. We have the HDP pipe is a fail-safe erection process. Of course, I don't have time to explain it in details, but if something goes wrong, you can always retract, like an army retracts when they think that they will lose if they keep fighting. They retract few steps and fight it again. That way, even HDP pipes can be, if there is a problem that you feel that the operation should be abandoned, it is possible. You can retract the pipe and relay it again in the next available tide. Now, there was a time when this technology was not available in India, but since more than 3 decades now, we have indigenous construction technology available, and I am part of it, of course, and there are few more agencies who can do the HDP pipe submarine installation successfully. Now, as I said, reconciliation, survey and assessment of marine conditions is a very important factor or a challenge, you can call it, before you plan any submarine project. The reconciliation survey is basically a seabed survey and a seismic survey which can classify the soil in the on the seabed. That tells you what kind of installation methodology you have to adopt. If it is a sandy soil, if it is a pure smooth sand soil is there, then the HDP pipes have a tendency of self-burial. Even after a couple of years, the pipe will itself go under the sand and be buried. So in such cases, dredging is not necessary. But if the seismic analysis says that it is full of rock, then a different design approach is there. Either you spend too much of money in dredging of that rock, or you ballast the pipeline in such a fashion that it can withstand the sea currents. So based on the impact of these studies, we had to design the piping system and the installation method. Now I said that we will talk about the pipeline stability. HDP pipes are lighter than water, so we need to weigh them before we put it on the sea floor or under the seabed. For sinking of the pipeline to the bed, we need concrete collars. So a typical picture is being shown here. they are very firmly bolted, because the installation process, it is a possibility that the blocks will slide and come together and an accidental sinking can happen. So it is to be very securely fixed onto the pipeline. As I said, when the pipelines are laid on the sea floor, if required, we had to put secondary weights so that it can withstand the sea currents. Seawater intake pipelines, the biggest challenge is leveling the pipe on the shore. When it comes near shore, in the intertidal zone, when it comes, the seawater has to flow from the sea into the seawater pump house on the shore. And mostly it is by gravity. So we have to maintain a gradient in the pipeline so that water can positively flow into the pump house or the sump at all times during the all tides, even the astronomically lowest low tide. So this is, the excavation depth goes up to 10 to 12 meters in some cases, where the ground is at a higher level than the sea. Normally it is more than 3 meters always, otherwise it will get merged into the sea. But sometimes it is 5 meters, 7 meters like that, and then we had to do a very deep excavation on the near shore area so that the pipe can come in a proper gradient into the thing. Now for this, you cannot do a open cut excavation of 12-meter depth, because your top width will be somewhere around 60 meters or so, and it is not normally permitted by the fishermen because their local, their normal movement is affected. So we had to go with a sheet pile enclosure and a sheet pile cofferdam so that peacefully the excavation can be done and the installation can also be done. Dredging of pipe trench. Now, for many of the cases, the Environment Ministry is making it compulsory to dredge the trench, because the pipe lying on the surface creates problems with the fishermen habitat. Their nets get tangled and they get damaged. So we had to, based on the seismic analysis of the area, we had to plan whether you want to go with excavator mounted pontoon, whether you want to go to cutter suction dredger, or you want to go with a grab crane barge. These all selections of methods will be done after the seismic analysis is done. Trench bed preparation. Actually, HDP pipe doesn't require trench bed preparation because you don't need to put a velvet or a mattress below the HDP pipe. It can safely be put on a sandy or clay soil. Now the installation techniques, fabrication and assembly. See, this is one typical photograph is of beach launching of the HDP pipe for float and sink method. But there are other methods also. This is when I said the initial survey, we had to find out also whether there is a clean beach available for fabrication of the pipe string of about 500 to 600 meter length. And if that beach is available, then we can go in for a float and sink method, which is being shown over here. Otherwise, there are possibilities that you can have a port nearby, and that port permits you to fabricate the pipeline in the port. You can as well fabricate in the port and then bring it to the site of installation. If both these things are not possible, we have to go with a lay barge method, whether the pipe is welded on the barge itself and then it is sunk from the barge itself. We can have longer pipe strings up to 500, 700 meters in the beach launching option. In the beach launching option, the most essential thing is the weld quality, because as I will come later on, the pipe undergoes high stresses during the beach launching and the welds must withstand it. The current equipment available are very good in giving a sustainable welding. Towing, positioning and sinking of the pipeline in beach launch method, we had to make the towing plan considering the currents in the sea, and sinking is normally done by flooding the sea water into the pipe. And if there are any mechanical, if you are going for multiple strings, then you need to have a mechanical joint in between. Now to understand how installation is done, I will present you a real-time video. This is from a recent site for Arvindo group of companies. They are putting up a desalination plant, and we have done seawater intake pipeline for them. For everyone to understand, I will just play the video. It is about 3 minutes video. May I request to play the video, please? This is typical beach launching. Now the pipe is fabricated on the beach. It will be pushed into the sea using this equipment, and as you will see in the next video, there will be a tug which will pull the pipe into the sea. You can see about 5 excavator cranes pushing the pipe in the water. Why we use this is because this has a very quick movement. These machines can move very quickly. Secondly, they can go into about 1 meter water depth, where the pipeline actually we need to float the pipeline. So they can go into 1 meter water depth and put the pipe. Now this first machine which has pushed the pipe, that pipe has started floating. So like that, gradually the entire pipe length, this is a 600-meter long string. So this will be gradually pushed and then floated and taken into the sea. This looks like a simple operation, but this is the biggest challenge of float and sink method, is to synchronize the tug pull and the shore push. These two things have to synchronize. The shore push cannot push too much, and the tug cannot put the full force unless the pipeline is floating. Now this is the tug which is pulling the pipe into the sea. We have to have a very long rope, almost 300 meters to 400 meters long rope we have to put. This is partly the pipeline has been floated. Part of the pipeline you can now itself see on the beach. It is not fully launched. This is the sinking end where some walls are provided. As you will see, the pushing is still continuing and the pulling is still continuing in a perfectly synchronized manner. You don't see any haphazard bend or any stress developed at any point in the pipeline, except for the bend. That bend is also very smooth. If you see, it is a 60-degree bend, which the HDP pipe can very easily take. It doesn't suffer any injury in such kind of thing. Now here the sinking has started after aligning. You can see the pipeline is in a straight alignment, which is being held by the machines on the shore, so that it sinks in the proper alignment. It doesn't shift from the alignment. This is a 1000 mm dia pipeline, and you can imagine handling of a 600-meter long string. And this, we get a very limited time window, 3 to 4 hours we get, within which we had to complete the installation. So this is a very big challenge to achieve. We had done total 5 strings at that site, and all went off without any failure or any hurdle. We had a local habitat issue here also. Now, what is the key to a successful submarine project? Proper welding, use of state-of-the-art equipment and proper welding, proper assembly of anchor blocks, right installation method derived after the study of the ocean, and proper air venting at the shore. That is very essential. Need for good welding, it has to tackle lot many stresses. The welding should be such that it should sustain some human error if it happens, increase durability, and for the client to avail the maximum benefits of polyethylene, which we proclaim. You can see in this installation, you can see the high stress zones. So these will sustain only if a good welding is done. I'll come to the key projects which we had done. 1200 mm into 3 pipelines for Nuclear Power Corporation. It's a something new Nuclear Power Corporation has done. For the first time, they have gone with a piped water intake system. This is from a river. Otherwise, they always go with channels. They go with open channels, Nuclear Power Corporations. Many of the power plants are there. Most of them are with open channels. But first time they have gone with piped after a lot of convincing, after a lot of marketing. We have done a very long offshore pipeline, 1000 mm by 7100 meters into the Arabian Sea at Nawapur coast. Friends, this happens to be the longest HDB submarine pipeline laid in this country. Then we had done 1600 mm diameter, which was at that time the largest diameter manufactured in our country. We had done for Minjur desalination plant, and we had done some fast track projects. Only because it was HDP we could do fast track projects. I will come to that. So this is one of the fast track project. This project is of Minjur. Their installation of the seawater intake pipeline, main seawater intake pipeline, was delayed for some administrative reasons. We were called upon, and it was a foul weather. It was August-September month, so which is a foul weather in the Bay of Bengal. So we said that we can lay 5 smaller pipelines, not 2 big pipeline, 1 big pipeline, but we can lay 5 smaller pipelines in the given time frame of 60 days. So we suggested 560 mm into 5 lines. System concept to commissioning was done in just 45 days. 5 lines of 630 meters each were laid in just 45 days. This was possible only because of HDP pipes. No other pipe can be installed so fast. And then when the foul weather receded, subsequently we also laid the 1600 mm dia pipelines for intake and outfall. The plant has been commissioned and is operating, supplying 100 mld water to Chennai. This is the same case story, 1600 mm dia pipeline for intake and 1600 mm for outfall, which was done in the fair weather season. This is the project where I said local habitat problem. This project was held up for 3 years. We were not allowed to work by the fishermen. And they were, they could get to violence also in that. So we couldn't venture onto the thing. But finally they settled with the habitat, and we got the clearance in the month of March beginning, which is the beginning of the foul weather. We had the confidence of previous fast track project, and we knew that HDP pipe can be done in this thing. This was a 3.5 kilometer long pipeline, and we had done it in a record time of just 34 days. Of course, our all preparations were ready because they were done outside. But on-site fabrication, towing, aligning and sinking was done in just 34 days. This is probably the fastest track project done in our country. Laying 3.5 kilometer length in 34 days is a Herculean task. I thank the audience for patiently listening to my talk. Thank you so much.
Thank you, sir. I do have some questions, but we will take it in the Q&A session. Now I would like to invite Mr. Prashant Nikade, Application Development Engineer at Buruj. Bigger, better, stronger, developments in PE 100 RC, black pipe material, is the topic that he is going to speak on. Prashant is a Senior Application Development Engineer, Infrastructure for Asia South region of Buruj for past 10 years. An agriculture engineering graduate, Prashant did his post-graduation in irrigation and drainage engineering from GB Pant University in 1990. He also holds diploma in business management and certification as lead assessor for quality management system. He started his career at Polyolefin Industries Limited, Plastic Products Division as technical service engineer. Later, he worked in senior positions in Nosil, Duraline Industries, and Reliance Industries before joining Buruj. He has diverse working experience over 26 years in various capacities in PE piping systems and micro irrigation in designing, product development, and management, project execution, production, and quality control. He has contributed for preparing national standards on PE pipes and micro irrigation as an active member of BIS CED 50 committee. He is a winner of 3 Buruj Innovation Awards and has 3 international application patents in his name. Welcome, Mr. Prashant Nikade. Okay, this paper is being presented by two of our speakers in tandem. So I will also introduce Mr. Chanchal Das Gupta. His topic is bigger. Oh, so it's the same topic. So I just give his introduction. Chanchal is Application Marketing Manager, Infrastructure for Buruj Asia South and in charge of marketing of Buruj PE and PP infrastructure products in Indian subcontinent. A chemical engineer from Jadavpur University, Kolkata, Chanchal started his career at Indian Petrochemical Corporation Limited in 1986 in technical service and application development for polyolefins. Since 2001, he is working for Buruj for market development of Borstar PE and PP grades for infrastructure applications. He has presented papers in many international conferences, winner of Buruj Innovation Award, and on 4 occasions, and has 3 application patents in his name. I would like to welcome both of them. You will be speaking from here, or you need? Okay, you have the cordless mic.
Good evening, everyone, and welcome. I thought our topic is challenges of being the last speaker, but then we found it's something else. And why are we presenting together? Because you know the blockbuster movie Sholay, Jay and Veer used to toss a coin whenever any task has to be performed. So we thought instead of tossing a coin, better let's do it together. And my job is very simple. I am non-technical, he is technical. I'll tell him what to present and he will technically explain it. So let's start our presentation. Where is the remote? Yeah. So this is the content. Introduction, development of HDP resin, pipe extrusion, diameter and thickness, significance of P112 and P100RC, what are they? How innovations provide cost savings, case stories and summary. But before that, we have the pleasant task of introducing Buruj also. Before that, Prashant wanted to give a new twist to the subject. So if you can explain what is this photograph.
Yeah, everybody think larger, bigger must be the metallic pipes. That's only the possible with the metallic pipes and not with the polyethylene pipes. So one can see the photo. This is 3500 metal pipe, and you also have a polyethylene pipe of 3250 So we are going bigger and bigger, and we are competing in terms of a size as well as the pressure class.
So Buruj is a leading petrochemical company, as most of you may be knowing, which provides innovative and differentiated polyolefin solutions, established in 1998. And pipe is one of our product line, but we also focus on energy, that is wire and cable, agriculture, healthcare, mobility, and advanced packaging in over 50 countries across Middle East, Asia, Pacific, and Africa. Tenfold increase in production capacity since 2001. Currently, it's 50 lakh tons of polymers in one single location, going to be increased to 64 lakh tons by 2027. And we have more than 3,100 employees globally. Now, again coming back to Sholay, you know, it was another movie where, you know, the hero is asking his brother, hero is underworld don and brother is a policeman. He is asking, मेरे पास बंगला है, गाड़ी है, बैंक बैलेंस है, तुम्हारे पास क्या है? So I often ask Prashant, इंडस्ट्री के पास P63 है, P80 है, P100 है, तुम्हारे पास नया क्या है? And what Prashant says is this.
मेरे पास MRS 11.2 का material है. So this was the story we started, and you know, we are moving from 1960 to 2020. It was a P100, and we have a P100, what you can say, stress crack resistance material, and then we have a RC, and then we also have what we can say is MRS 11.2 material. So things are moving, and when we say that kind of a MRS, what exactly it means? So the people from the industry, Nisha covered that topic, but let me explain you. So basically when you do the, how you classify, it's not like a, you know, within 1 month the exercise will be done. It is a 10,000 hour test, 132 samples of 32 mm tested at various stress levels and the temperatures, and then you have a regression graph, which what we say is the MRS graph. And it's not easy. So the failures honestly happen, and Nisha said last time, so at the last moment it will fail sometime. So what you can see here, we have a classifications where we can see the top, which is at the 23 degrees centigrade. But earlier it was, you know, we used to do at 65 and 80 degree. And here what we can see is that the 50 years, when you talk about the 50 years life, which is a requirement of ISO 9080, we are talking about the 11.2 to 12.5 extrapolated based on this. But you can also see that we are also talking about the 100 years very, very comfortably. So if you see this particularly, the points over there, we are talking about 100 years. So it's a wonderful that we are not talking about the topic of presentation. Theme was the sustainability. We are going over and above, and we are talking about the 100 years of life. So next generation, probably we are giving the better material, far superior material. Then also we are doing the, you know, there is a requirement in the 9080, the material should not break. There should be no failure, early failure. Apart from the long term, there should be no failure after the 5,000 hours at 80 degree. So we raised the bar, and Nisha said, last time if you remember, it's the complete team, complete properties have been lifted. So we are talking about the 90 degree centigrade, not 80, but we are talking about the 90 degree, 10,000 hours. So much is the better classification, better material. Then we have a RC, that is a resistance to cracking. So now we have seen the installation practices, we have seen a video, you must be imagining what the stress levels the pipe will have gone. So these are the things, and we are talking about, you know, even there is a slow crack growth, we are talking about the 8,760 hours, say complete 1 year. And then ISO 4427 and ISO 4437 requirements are 500, but we are exceeding that. Next slide. Is it only the raw material and the testing? No. The standards are also getting aligned. Internationally, if you see, the standards are also getting. The Indian standard has been raised because the Jain irrigation started producing the pipe 2,500, and so the Indian standard also increased the, you know, the range from 1,600. We have gone to 2,500. The ISO 4427 had gone to 3,000. And to accommodate this kind of for the bigger, larger kind of a pipes to produce, you need a material. So you need a MFR range, change in the MFR range. So from 0.2, it had come to 0.15. This is not done only in ISO, but also in the Indian standard. So then we have like a pipes talking about 25 kg. People used to say plastic pipe can't go beyond like 8 or 10 kg or 16 kg. Now we are talking about 25 kg pressure applications. Just to give you an idea, when you talk of the thicker pipes, so 3000 mm SDR 28 is a PN8 pipe, has a thickness of 153. People talk about 160 mm pipe or 140 mm diameter pipe. Now we are talking about 160 mm thick pipe. So that's the difference. So even the 900 SDR11 PN16 will have a thickness of around 100 mm. So the things needs to be robust, things needs to be practical, and something it has to deliver to the industry.
But as long as we are talking of material development, going to the higher pressure or a bigger property triangle, the challenges to sales and technical people is that how we can convert it to good application for the industry, how we can use this property to save money for the customer. So our presentation will be mostly focused on this application and how to put these properties into good use to make more shared value. So we'll be talking on breaking the limits of large diameter thick walled pipe, there the material is not enough. A good material, you can make a bad pipe. A good pipe, you can spoil it by a bad welding. And with bad installation, you can destroy everything. So Prashant will further elaborate on this.
Yeah, the scope, when you talk about the large pipe, it is only the, the reason, or it's only the production? No, it goes beyond that, because when you talk about the large diameter pipes, we have to consider the raw material. We need to have a very big material handling system. People are talking about 2,500 kg to 3,000 kg output machines per hour. So the material has to be handled in a far bigger way. Then we need a better production equipment. One can imagine if it is a 3-meter pipe, probably you will need a lot of ladder to move and see the things. The quality assurance process. So because if we do the testing of the pipe, you need a bigger things. Because the 3-meter diameter pipe, when you want to put into the hot water test bath, and you want to test the 3 samples, so it will be running around, you can just imagine. So then the joining is also critical. So what exactly you need a best material, quality, so that it can produce a quality pipe, best joining methods, best quality fittings, a quality tooling, and of course, quality installation. Then if you see this, the maximum wall thickness when you talk about that pipe material can be used, produced, depends on pipe SDR, because the lower the SDR, it is tougher. Higher the pipe SDR, that will be the SDR means diameter divided by the SDR. If you means 11, so if it is like 110 diameter, and if you say SDR 11, so divided by 11, that will give the thickness. Then we have a material properties. There will be viscosity. There will be lot of things which we'll talk about, and Nisha has covered that. Then the machine quality, how the extrusion quality, how is the machine set up, and of course the human factor, that is the skill of operation. And when you talk about the joining, when the things are bigger and bigger, naturally the equipments will also go bigger and bigger. Because you want to weld a 2,500 pipe, you will also need a machine which can take that kind of a pipe. So the butt fusion still is continued to be the favorite in case of the large diameter. People are not going with the other technologies. It's a time-proven technology. The standardized fusion process as per the ASTM and DV standard is permitted. Then one has to look the joint integrity, flow stream security, and job site efficiency. So is it only the theoretical part what we are talking about? No. This is from when we talked about actual testing. One can see that the tensile second foot picture, the first picture is 900 mm welding machine. Second picture, a thick 70 pipe was, you to cut and see the weld quality through the tensile testing. Then we have then we do the side strip testing. So you cut the pipe and then you build the strip and then you can do that thing. You can see such a thick pipe, but you can see the weld integrity. Can see here, probably Chanchal, you can show this way. So this is a clean surface, absolutely clean surface. So it is not only that thing, you just have a resin, but you have to go to the last milestone and see that thing, the welding and everything, the integrity of the pipe is assured.
Now we'll talk of cost savings with better low sag performance. No innovation is fruitful unless it saves cost. So when we talk of that, what is sagging? I'd request Prashant to explain.
Sagging, we have seen that because when you run the bigger thick pipe, the line speed is low, or you have a mid-size pipe and there is a thickness in the pipe. So the material gets chance to sag at the bottom naturally because of the gravity. So this is a perennial problem with the when the piping material, and it can create, what you can see the picture over there. You see when you use the normal machines and this, so it's very difficult to get the uniform thickness. One time you may think, if it is not uniform, what will happen? Because you can't maintain the minimum and maximum thickness in the tolerance, then subsequently it is not possible to weld the pipe at the site. So uniform thickness is very, very important. That's the sagging problem. So it has to be, this is the most top priority, because if your pipe will get reject if you are not able to maintain. Then look at these phases. If you have like a SDR 41 to 26, you will always have a happy phase. Your production machine will be capable. Your existing material will be able to, deliver that kind of a thing. It is possible to produce pipe. But once you bring down from 41 to 21, probably the few sizes you will have restrictions. And if you go from SDR 41 to 17, you are coming down. You are reducing your pipe sizes, capability. And if you're really going for a thick pipe, say like a SDR 11 and 9, you start crying, because what the machine which was capable of producing a 3000 pipe diameter, it had now come to the almost like a 1600 So it's deteriorating. So the graph goes down and down. So that's the importance of the wall thickness and capability, because of the the sagging property. And one can see very easily, what is important is that you save the material. Almost like a 9% will say. People will say, no, that is not only by the wall thickness. But who will consider the rejections? The people who are producing the larger diameter will tell you, either you produce a 9-meter pipe or this pipe, then check the wall thickness, then again make the settings. Again, probably you may take a 12-meter pipe, then again change the thicknesses. If you do the 3-4 iterations, you will come to know that already you have produced a 50-meter pipe. And if you look at the, it will run into 10-20 tons. So that's a cost of rejections and cost of time it will take. So it is very important. Here is an example. If you are not able to maintain thickness, this will happen. But if you use the good quality material in probably the same machine, so it is what you can achieve. So here are some example: 1200 SDR 11, thickness is 109. 2000 pipe with SDR 21, where the thickness is 95. Then we have like a 1600 SDR 17, thickness around 95 to 100, and DN the 800 dyne, SDR 11, thickness is 73. So the things are moving.
So now we come to how longer life and withstanding severe installation techniques are possible with high stress crack resistance. Now there are several tests to evaluate what is the resistance to high stress crack, And every year there are newer tests being invented because people want the material which fails in longest time to make it fail in shortest time. So most severe, most accelerated tests are being developed. Here are some of the very critical tests which Prashant will tell you.
So how we do the testing? Because notch is the first property which from where if you have a notching of the pipe, that's the first chance the pipe may get failed. So one is related to accelerated notch test, which is known by the ANPT. Then we have a FNCT test, which is a full notch test. Strain hardening, because we can take out some dumbbell and then test it, how it fails. So essentially, then we also look for the round bar. Then we talk about the, the square bar. So what we do is you do the notching and then you have in the solutions and we try to see whether it's failing. So these are the long RC kind of a new things which have been incorporated. So then everybody think why this is happening. This is happening because the challenges for the polyethylene pipe in the larger diameter and the other ways, so they are increasing. You have seen, under SDD applications and everything. So all these things practically has to get converted into, the raw material. All this should be able to meet this requirement. So that's the RC requirement.
And what you can see here in the last column is that our P112 plus P100 RC material, it has cleared all these international tests. So we are excellent as far as notch resistance is concerned. Therefore, these pipes can be used for very severe installation techniques.
It's now like Chanchal, it's like a hurdle test, You first take the MRS, then you move to the hydraulic test, other things. Then you have NPT, then you have RCP, then you have all these tests. These are like a hurdle.
Then you have point load test.
Point load test and all those things. So things are different and move.
So now we come to longer life with higher abrasion resistance and how that can give you cost saving and economic advantage. Now we have benchmarked these materials also for abrasion resistance because abrasion resistance increases with molecular weight. Higher molecular weight will have better abrasion resistance and also with longer side chain branches which will give more entanglement. So we have done abrasion resistance test as per ASTM D4060 using both C10 and C17 abrasion wheels. They will perform a specific number of rotations, maybe 5,000 or 10,000 cycles, and then see how much material has been abraded out of the specimen. So as you can see here, we have tested these, as you can see here, we have tested our P100 material, which is industry benchmark 3490 LS, that is a standard P100 with this new material and a competitor material. And you can see the loss due to abrasion is the minimum here for C17 as well as C10 wheels. So this means that under abrasive applications of conveying very abrasive fluids, etc., these materials will stand much longer and you can use probably lower thickness or give more life with the same thickness. So Prashant will present you a case study like this.
So when we do the abrasion test, where it can be? So everybody knows when you talk about the slurry transportation, where there is a solution of the solid and the liquid, when it is passing, especially we are talking about the mining operations, we are talking about the sand silting, you are talking about the dredging. So all these material will abrade the pipes. So I'm just presenting a case where the Tata Steel, they do a lot of solid transportation, and one can see that thing, that these pipes have been used. It's like a 630 SDR9 pipe. It's not, like a 21 or something. This is SDR9 pipe. And this is something like where the pipes are rotated. They are flange joint. They are taken depending on the site. Where the site is moving, they will move the pipes. That's why they are flange. They are not, one line. and then they start rotating the pipes, say 90-degree. Once after some time, they will rotate to 180, then 270, and probably we are back to this thing. So that you don't abrade the one section. So keep on doing abrading this thing. So you, instead of having a life of 4 years, you can achieve at least 3 times is 12 years. So this is excellent material, and this property can be very useful for this kind of application.
Now coming to reducing pipe thickness with higher MRS material. This is the most often asked question, that yes, you have made P112, but you don't have a table in the standard corresponding to dimensions of P112. So how you can do the cost saving by down gauging and taking things like that. For large projects where design can be done from the basics using MRS value with approval from the client, there are significant savings in pipe cost. And we have done some calculation which Prashant will present in next 2 slides.
Yeah, the wall thickness is always calculated by the very simple formula, P into D divided by 2 sigma plus P. That sigma value, the MRS value at the bottom. So you increase the sigma value, the naturally the wall thickness will go down without compromising on the 50 years or 100 years of life. So what we try to show you is that if you use a higher MRS material, that is 11.2, you can reduce the wall thickness of, if you talk about the 1000 mm, it is 52.9. You can come down to 50.3. So that's a 50.
From 59.3 to 52.9.
This. So this is the good advantage what you can achieve. So many times the customers do not want to pay if they feel the material is assured material and it can, through the MRS is certified. Why don't you use this and translate this into the weight saving of the pipeline?
And there is another way of looking at it.
Sometimes people say, no, I want the same wall thickness SDR. I do not want to reduce the wall thickness. Then what will happen is that these are all for industrial application. And industrial application, the safety factors are very important. If you talk about the sulfuric acid transportation, or we are talked about the vegetable oil transportation somewhere. So they always talk about, what's the safety factor. So normally in the water, we take 1.25 factor of safety, but a lot of people need a higher factor of safety. They feel there should be some security. So if you go with the, you can see here very clearly, if you go with the same wall thickness, so instead of 10 kg, you can talk about 11.2 kg. So there is a incremental of 10 to 15% pressure class increment. So you have a little more factor of safety. Instead of 1.25, you can always have a little higher, and this is at the lower confidence level.
Or you can even do less pressure derating because already your
Yes,
pressure
that can be
resistance
also
is
possible.
high.
So the tailor-made situations, and depending on the industrial customers, we can take a call on that.
Now we'll summarize what we discussed so far. Before that, we'll just show you the trend-setting projects in Middle East and India region. Some of the good projects like Borouge, Abu Dhabi, we ourselves have installed a lot of these large diameter pipes, and we had to really convince the EPC consultant because they also did not believe in HDP pipe, but we had the confidence that these materials can replace GRP or other pipes which have been used in Borouge 1 project, and we had several failures. And in any petrochemical complex, one failure of cooling water pipeline means several days production loss, so which means a lot of money. So the EPC consultant had agreed, and they have installed 4 into 2.8 kilometer intake pipes and 6 into 2.3 kilometers of outfall pipes of 1600 diameter. Then we had some excellent project with ZADCO, that is submarine water disposal, which is a oil-water mixture from an island to offshore. This is 560 millimeter diameter and 80 millimeter wall thickness, which is SDR7, and it was used for 25 bar produced in Abu Dhabi. Then, as Samudra Sahib has already told, that couple of years before he has supplied to nuclear power project, and recently again the Kakrapar nuclear power project, where HDP materials have been used for their passive screen intake with air backwash system, where P pipes up to 900 millimeter diameter has been used. It has been used for Barkat nuclear power project in Abu Dhabi. Now, use of P pipe in nuclear projects needs lots of approvals, test reports, and documentation. Fortunately, we could meet all those requirements, and therefore our material has been used for such projects. And then done by Jain Irrigation Seawater Intake and Outfall Pipeline, Bharat Heavy Electricals Limited. They have 2 into 800 megawatt Udangadi supercritical thermal power plant, where 2000 millimeter diameter SDR 26, 4.1 kilometer has been used. So, summarizing the cost saving opportunities, very large diameter pipes beyond earlier limits, replacement of traditional materials, lower pipe thickness versus P100 for same pressure through design calculation, you can have about 10% material savings, higher pressure lifetime for same pipe thickness at elevated service temperature, because we have done 10,000 hours test even at 90 degrees centigrade, which means higher lifetime. Better low sag performance can save you anything between 6 to 7% material savings, and higher abrasion resistance for slurry pipelines gives you longer life. So material savings and longer life, which means sustainable solution, which is also the theme of this conference. Thank you very much for your patience.
Thank you.
Very interesting presentation in tandem. Thank you. Now we would like to invite a couple of questions before we go to the next, the finale of the event. Anybody has any questions? Can you please send a mic to Mr. Rajesh? Okay. Your name, please.
I'm Vishnuvardhan from HPCL. This is to the Burroughs team. The first one is the revision in the I5 from 0.2 to 0.15. Is it conditional or is it without any condition? Because I believe it's a conditional change from 0.2 to 0.15.
No, it is very clear in the standard. The lower limit is 0.15, and the condition is that you should be able to maintain that. So it's not like probably many times in the standard it is given if MFR is 20% variation is allowed. So they said that the limit has been fixed to 0.15. So probably for us, you don't change that much of MFR, and density don't get changed if you are using only convert the granules to the pipes. So I think because of that, they have put that clause, because you will not be permitted to add anything and you should not go further below.
I am talking with respect to, I think it is conditional with respect to if there is a butt welding and a electrofusion joint. I think it has taken a cue from the ISO. Is it so?
Yeah. See, all Indian standards are based on, slowly we are adopting the ISO. Even jumping to 4984 from 2097 to this 16, there's a one step forward close to this, to ISO standard. And when the ISO standard changes, there will be adaptation of that standards to Indian conditions. So only thing is that what we do is that instead of ISO takes at 20 degrees centigrade, we take at 27 degrees centigrade. But the rest of the testings and the material qualification process and all those things, we are keeping our identity the same as ISO. In fact, any standard, if you want, the BIS will first ask you whether ISO standard is available. And top of it, now many standards, including the MRS 9080 has been adopted in the dual series. So Indian standard number has been given, but you can see very clearly it says ISO 9080 stroke Indian standard number. So we are not reinventing anything. Wherever there are fixed qualification, we are adopting to the ISO standards.
The only change being ISO is compound, whereas Indian standard is still the resin, because we do not, Indian manufacturers still do not do the compounding.
Yeah, that's why the you have to keep on telling, and that's what we use this such kind of a platforms to tell people what exactly ISO and why this has been done. It is not only ISO has done it and you follow it. No, why we follow it and why ISO standards are based on that. Because ISO is a global kind of a thing. So there will be a lot of objections and raised and everything. So that's the way we are dealing with this situation.
Okay.
Can you pass the mic to Mr. Rajesh?
Yeah. For a change, no question, but only two small observations. Feeling relieved. Mr. Samudra, thank you so much for that video which you have shown, which I believe many of us would have seen it for the first time in their life. So it was really very interesting. I mean, your presentation apart, that was really, really, good. And Mr. Dasgupta, there is one more Viru Jai Jodi in this hall. Can you tell me? Apart from yours. एक और जोड़ी है इस हॉल में वीरू जय की. Okay, fine. Mr. Pillai and Mr. Sangvi. And they have done this unbeatable, this conference.
Thank you.
And need I tell you the Thakur's name, or you can imagine?
No, you are wrong. There are three musketeers, Ramesh, Haresh and
No, that is the
Rajiv.
Thakur's name. Thank you.
I had a question for Mr. Girish. We have seen that recently a lot of pipeline is now produced on the seashore and going directly into the sea. Do you see more of this trend coming up, or there are some limitations to that?
See, there are more and more opportunities coming up, basically because now HDP pipes have made kind of a setting, in desalination plants, in effluent disposal, river water intake, with nuclear power using this pipe system for the first time. When their conventional system is always they dig a channel and do it. So, and in fact, they had gone with a RCC tunnel and the contractor failed to do it. He finally raised the hand that I cannot do the concrete tunnel over here because of the certain limitations of the site. And they changed over to HDP. So now more and more, nuclear power is also planning more projects now with piped intake only. And now there is, this entire coastal based industries, the government is pushing them to the coast. Most of the industrial areas are being developed on the coast. Power plants are being taken to the coast because the government says don't ask potable water for industrial use. Please use seawater. So this is the pressure under which all the industries will move to the coast, and naturally there will be a demand for HDP pipes, very high demand. HDP pipes have made a landmark image in all these projects.
Thank you, sir. Thank you. So I guess we will go to the last part of it. I would like to request Harish Pillai to come onto the stage, and I think we should, we still have to give the mementos to our speakers before that. Can we have the mementos, please? Mr. Harish Pillai, can you come and do your... Momento to Mr. Girish Samudra. I will give it to my colleague in the committee, Mr. Chanchal.
Thank you very much, gentlemen.